So hi everyone. So this video I will cover section 4.4, the mean theorem. This is pretty important in calculus. Before we talk about the mean theorem, we also look at the Rolle theorem as well. It's also one of the important theorem that you should know. And let's see what this theorem talk about. The theorem say, let f be a continuous function. So this function is continuous, no break, no jump in between, over a closed interval and differentiable over the open interval. So it means every single point between this interval, the function will be able to take a derivative. Okay, it will be defined such that f of a is equal to f of b. Let's draw a picture for you to visualize this. So you have a continuous function. So any type of continuous function like this, okay? And the important thing is they're going to be continuous between an interval from A to B. I don't care what happened outside of A and B, but between A to B, they are continuous. And another condition is the y value or the output of this two value must be equal to each other. So it's let's say if this is a function f of x, then my f of a and my f of b must be equal to each other. So this graph, yes, look like the same because they have the same y value. So this is the Rolle theorem will hold. And the Rolle theorem say that as long as these conditions hold, then the Rolle theorem will guarantee that there will exist at least one c in the interval such that f prime of c is equal to 0. And that is true. Between these two values, I can get some of the value in between that and have the derivative f prime of that value is equal to 0. So as long as the condition is whole, this will be true. Okay, so the Rolle theorem will guarantee that. So it doesn't necessary to be one value of c. It sometimes could be more than one if you have the graph like this, right? Let me draw a different shape. Let's say you have the graph, they have the same y between A and B. Okay, but the graph can be any shape like this, okay? And the Rolle theorem is, so the graph is continuous and the y value is the same for both value A and B. Then the Rolle theorem will guarantee that there will exist, always exist, at least one C such that f prime of C equals 0. And this problem, they actually have three C. So you have f prime equals 0 here, f prime equals 0 here, and f prime equals 0 here. Okay, so this is how the Rolle theorem apply. So let's use the Rolle theorem to see we can find the value. So I have two problems. So use the Rolle theorem to verify that the function satisfy the criteria. So we need to check the condition first. And then if that is holding, then we're going to find a C value such that f prime of C is equal to 0. Okay, so now the first thing that we're gonna do is we're gonna have to double check to see, is this a continuous function? Yes, this is a polynomial function, continuous everywhere. Okay, so domain of this function is all real number. So yes, f of x will continuous on -4 and 1. Now we have the first condition hold, and the derivative of this function is also defined between -1 and -4 and 4. Now we're gonna check the output. If I find what is f of -4 and what is f of 1, does that equal to each other? So let's try that. So f of -4 is -4 squared plus 3 times -4 minus 4. And now let's put that in the calculator or whatever, mental math, whatever you want. And then we're gonna have -4 minus 4. So we have this is 0. Now we're gonna check f of 1. F of 1 is gonna be 1 squared plus 3 times 1 minus 4. and that also will equal to 0 by looking at it, but you want to double check with your calculator, it's fine. Yes, and that does equal to 0. So f of -4 is equal to 0 and f of 1 is equal to 0. So it's all the criteria in the Rolle theorem, right? Then we can say there will at least one C such that f prime of C is equal to 0. Therefore, there will exist, okay, because all the criteria is holding, so they'll guarantee that there will exist at least one C such that f prime of C is equal to 0. And this is by the Rolle theorem. Okay, this is a guarantee. If the problem doesn't ask you to find C, then you can stop it right here. Okay. However, the problem is also find all the value of C such that f prime of C is equal to 0. So we're gonna do the second part. So how do we find f prime of C equal to 0? The first thing that we're gonna do is we're gonna check f prime. F prime of x will be 2x per 3. And we set that equal to 0. We have x equal -3 over 2. Right? So this is going to be our C. And this C will be fall within -1 and 4. So C is equal -3 over 2. So that answers the second part of the problem. Now check the second equation. All right, let's take a look at this example. I have f of x equal x cubed minus 4 on -2 and 2. Now we're going to check the condition. So we have this is a polynomial. So f of x will be continuous and differentiable. On -2 and 2. Okay, so and then we're gonna have to check one more condition, which is f of a and f of b. So f of a is -2. So f of -2 is -2 to the power 3 minus 4 times -2, and that will be -8 minus plus 8 is equal to 0. F of 2 is 2 to the power 3 minus 4 times 2 will be 8 minus 8 equals 0. So look like they have the same output. This is the same. So the Rolle theorem will apply. If you have something like, if this is not a 0 and also 0, but this is 16 and 0, then the Rolle theorem will not apply. So this is 0 and 0. So the Rolle theorem will apply, will be satisfied. So by Rolle theorem, there will exist satisfied, and then we will be able to find a C, that f prime of C is gonna equal to 0. So, and that C will be in between this interval. So we're gonna do f prime of x will be 3x squared minus 4. Okay, set that equals 0. We have x squared equal 4 over 3. And then we square root on both sides. We have plus and minus square root of 4 over 3. So this is going to be the C value that between -2 and 2. So you can check the results. Square root of 4 over 3 is actually 1.5, right? So -1.5 and 1.5 is actually fall between -2 and 2 because Rolle theorem apply. So once again, if this two value is actually two different value, then the Rolle theorem will not be applied, and you will not be need to find the C value. You don't have to do this step. All right.